Good morning, guys. So, Sir DV is here again. Continue our discussion on minimum loads as per NSCP 2015. So, last time we finished our discussion on dead loads. So, this time we go or move over to section 205, live loads, which are defined as those that shall be the maximum loads expected by the intended use or occupancy, but in no case shall be taken less than the loads required by this section as set forth in Table 205-1. Okay, let's first take a look on the table cited on that section. So this is Table 205-1. So very informative in the sense that for all the most common buildings, uh, occupancy and category are defined here, including their components or the sections, such as the access floor system, exit facilities, uh, etc. Okay, so you also have a choice on the type of load that you are considering, but take note that in this particular uh, choice, we need to come up with the most or the more critical of the two. So when you say more critical, one who will be giving you the maximum stresses in terms of flexure, maybe shear, specifically for continuous structures, because shear and uh, flexure always go in hand, uh, considering the flexibility of the structural members concerned, just like a beam or a column. Okay, so we can see here a more common building category like offices, residential, okay, schools, storages, etc. So you can refer to the minimum design load uh, suggested here, including the concentrated loads, which has to be dealt with accordingly by some notes here below, and we shall discuss them one by one. So for the first provision on live load consideration, we have the reduction of live loads, which is section 205.5. And this is based on both the table 205-1 and table 205-3 method 2, which actually sets a value for R, okay, which is the rate, okay, of reduction. Okay, so this R here is simply the rate of reduction given on this table. And this is simply multiplied with the excess area. Okay, so this is simply an excess area coming from the actual area, the tributary area of the members supporting, okay, the floor. Let's say I have here a column which supports a tributary area, say, based on my geometry, a 5 by 5 meter area. So the area here that is being considered is simply 5 times 5, which is 25, sorry. Square meter. Okay, so if I want to compute this uh, reduction, I simply multiply the rate, say 0.08 for flat roof or flat floor. Then I simply uh, take the excess of the area 25 from uh, this 15 square meter that was set as a reference. So I have here simply 0.8 by 10. Okay, so this is simply 0.8% reduction. So it's not quite very big because the area upon which the column is placed to support is only very small. Okay, but if you are talking here of very large area, such as those area from storehouses, the warehouses, um, uh, we can actually obtain a larger rate or a larger reduction factor R in this regard. And this has to be checked on the limitations. So the value here should not exceed, okay, so the R computed should not exceed this 3, okay? Where in these 3 limitations are based on the members receiving loads from one level only. So you take note if this column is only receiving a load from one floor, you use 40%. If not, you use 60%. And you have to check it on the basis also of the dead to live ratio. Okay, so the dead to live load ratio. Okay, so if the dead to live load ratio is big, then your comparison will be bigger. Okay, if the dead to live load ratio is small, then this becomes smaller, which means that the live load is more critical than the dead load, such that your reduction limit becomes smaller. So take note that this is only true for cases except floors in public assembly. Okay, so also when the live loads are greater than 4.8, you cannot apply the reduction of live load. But in storage, wherein the loads are greater than 4.8 kilopascal, you may not apply the reduction formula, but automatically for the columns, no, considered in such a situation, we can reduce the live load by 20%. So automatic columns have a special uh, treatment when it comes to reduction of live loads when the storage loads are greater than 4.8 kilopascal. Okay. So I just like to proceed with my notes here on section 205.3.3 for the area of load application. Okay, so if I may continue, we are now bound to compare always, okay, the effect of a uniform load and the effect of a concentrated load. So here's how the concentrated loads are applied in terms of area concentration. So load concentration shall be over an area of 750 square millimeter square located so as to produce maximum load effect. So this 750 millimeter square is actually the size or the dimension of the area upon which the concentrated load in general should be applied. Okay, so this is the area we are considering here. So for vehicle storage, which are not defined, no, in terms of its weight, then we simply multiply 40% of the gross vehicle weight to use as your concentrated load L. So L here is simply 40% the weight of the uh, vehicle, okay, which will be used as concentrated load space at 1.5 meter on center without considering the uniform load set forth on the table. Okay, and then we compare and then find out which of the two uh, scenarios yields the more critical result. uh, that's what we are going to use in our analysis and design. Okay, for private parking loads with no repair or refueling, so this pertains to very light, no, light vehicular loads such as cars. Okay, we consider a specific weight of 9 kilonewton, which is more or less 900 kilos, the weight of a car, acting on an area which is equivalent to 0.015 square meters. So this is now automatically a 0.015 square meter of area. Here, the area still has to be uh, computed. So this is more or less a point 0.5 something square meter. Okay, so this is approximately. So for special roof loads, roof to be used for special purposes shall be designed for appropriate loads as approved by the building official. Uh, but for greenhouse, okay, greenhouses, which is a type of a special roof, then the roof bars, the purlins, these rafters shall be designed to carry automatically 0.45 together with the uh, uniform load as set forth. So this is simultaneous application. Okay, not unlike the vehicular load here where the uniform loads are not computed in addition to the concentrated loads. So for the table here for special loads, okay, we have some very good categories here that we may use, no? when we have some situations, okay? So walkways and canopies for construction. Okay, grandstand, these are the seats and footboards. So these are the vertical and the lateral loads. Okay, so if you want to make specifically some computation on catwalks, okay, on stage accessories, just look into this description here. No? Balcony and railing guardrails, exit facilities. Okay, so you have here lateral loads because this is very dangerous. No, when the railings are not secured, then accidents can happen. No? The vertical load is not a factor here, but the lateral load are the ones that are very important. Okay. Also, the vehicle barriers here, lateral loads are very important. The handrails, see note 10. So we just read note 10 here about how the handrails are being considered in terms of design. Okay, so this is at least 890 Newton, which is around 89 kilograms of a force applied in the direction at any point on the rail. Okay, so not necessarily horizontal, but the point we're in, it is critical, no, based on how it is anchored or supported on the floor. Okay, so we have here fire sprinkler supports. Okay, so if you are designing a fire detection system, alarm system with, of course, the sprinkler system included, then we need to consider a weight of 1.1 kilonewton plus the weight of the water filled pipe vertically attached or vertically supported to the components of your building. Okay, so these are very helpful provisions and suggestion references for us to deal with the live loads on buildings. So we will be using some of this later when we arrive with the general procedure on how to analyze reinforced concrete structure later. So thank you very much for listening and have a nice day.